Hello friends, I hope that your week is going well. Today we are going to continue talking about physical properties and states of matter. Yesterday we talked about physical properties and how that is something that you can observe. You don't have to change that piece of matter or that substance in any way. You can see it, taste it, smell it. Okay, use your 5 senses to determine or observe the physical properties of something. So today we're going to talk about some other properties of matter. So I am on page 114. If you have your book, please get it out, and that way you can read along with me. If you would rather read by yourself, that's okay. Just remember that you have the option to listen to me read, and also you will have my notes under today's date to read, and you can even take more notes on your own. Okay, so page 114. Each state of matter has different physical properties. Liquids and gases both flow, moving from place to place. Gases can expand, taking up more space, or compress, taking up less space. So we are going to hop over to page 115 and talk about solubility. Solubility. The water does not change the glass pitcher or the wooden spoon, but it does change the sugar. Solubility is the ability of a substance to dissolve when mixed in another. My favorite example of this is hot chocolate. When you put that hot chocolate powder into your milk or into your water, whichever one you use, if you try and separate that back out, it's not going to be very easy to do, okay? So your chocolate powder dissolves into your milk or water to make hot chocolate. That is solubility. Same thing when you put sugar in iced tea or lemonade, or if you put salt in water. If you've ever been to the beach and ever tried to separate the salt from the water, it's not easy to do, okay? That's because salt is soluble or has the ability to dissolve in water. We are not going to worry about page 116. On 117, I want you to take note of freezing and boiling point. So for water, the melting and freezing points are 0 degrees Celsius. The condensation or boiling points are 100 degrees Celsius. So water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. That might be on one of your assessments, but it should also be a review. That's something that you should have heard before. On page 118, we're going to talk about magnetism. So it says magnetic versus non-magnetic. Have you ever used a magnet to hang paper on your refrigerator? Magnets produce a force, which is a push or a pull. They can pull together or push apart magnetic substances. A magnetic substance such as iron and a few other metals is attracted by a magnet. A magnet also has no effect on non-magnetic substances such as paper, wood, or glass. If you've ever used a magnet, you know that it sticks to some metals, which means that that metal would be magnetic. You know that if you hold a magnet to a piece of wood or plastic, it's not going to stick because that wood or plastic is non-magnetic. Okay, so that is also a property of matter. Magnetism. Is it magnetic or non-magnetic? Page 119, I want you to look at thermal conductors. The metal in these pans are conductors. Metals conduct or allow thermal energy to pass through them. So remember, when we see the word thermal energy, we're going to think heat energy. So the metals in these pans are conductors. They allow heat energy or thermal energy to pass through them. Other substances such as plastic pot handles, wood spoons, and cotton oven mitts are poor conductors of thermal energy. They insulate or keep energy from moving through them. So that's why if you have ever taken something hot off of the stove, you might use an oven mitt because it's not going to burn you. That heat energy is not going to travel through that cotton oven mitt to your hand because that cotton oven mitt is an insulator, it is not a conductor. So conductors allow thermal energy to pass through, and insulators stop that thermal energy, or they insulate the thermal energy. They do not allow it to pass through. All right, electrical conductors are very similar to thermal conductors. Metals are also good conductors of electrical energy. In the diagram, the metals in the plug and wire conduct electricity into the toaster where thermal energy is produced. The plastic in the plug, socket, and around the wire are electrical insulators. They keep electrical energy away from your hand. So that's why in any type of wire, you've got plastic around the metal that's inside the wire because you need the wire so that the electrical energy can pass through, but you need the plastic covering so that you don't get shocked by that electrical energy as it's traveling through your wire. So insulators do not allow thermal or electrical energy to pass through. Conductors do. So it allows electrical or heat energy to pass through it. Alrighty. Again, I have done notes over these pages for you. So I would encourage you to look at my notes, read them, write them down, and add your own things to help yourself remember as well. All right, have a great day.